I've got here an interesting device called a force table, sometimes a force board. It's a great way of seeing how forces add and subtract in multiple dimensions. So how does it work? It's a big metal disc, it's got notches in it, and on those notches you can put these fish scales. Let's zoom in and take a look at one. If I pull it, you can see there's a spring inside, and the more I stretch the spring, the more that little arrow goes down the scale. It's measuring the force on the spring. Physics class, we usually call these spring scales. Most normal people call them fish scales, because if you go fishing and hang a fish from this part, and then lift this part up, you can see how much the fish weighs. They're a great way of measuring force. And they've got kind of an interesting setup here. They're all linked together in this ring. So the ring's not accelerating. It's standing still. Its motion is constant. And what that means is that in all dimensions, there must be no net force. The force has to add to zero. Sigma F is 0. So what dimensions are there? Well, it's a plane, so that means 2. And we can specify the x and y axis however we want. So I made a little reference frame here. And I'm going to make this my x and y axis. In other words, the two scales currently hooked up are along the y axis. And I'm going to pull this guy, and you in lab are going to pull this guy towards the right. And our reference frame is not moving, just this piece of paper is. This is always going to be the y axis. This is always going to be the x. So let's look at what the scales are currently doing. As you can see, they're reading about the same. They've already got some force on them, and that force is equal, showing that all the upward force from this one is being canceled out by downward force from that one. That has to continue to happen. The forces in the y dimension have to sum to 0 if the ring is not moving. But look what happens if I pull the third one to the right. Obviously all three scales increase. But now the two that were just pulling up are now pulling back to the left. But they're still pulling up or down. And that's kind of the key thing. This rightward force, because the ring is not moving, has to be canceled out by a leftward force. Where's the leftward force coming from? The two scales that were previously just up and down. Now they're still up and down, so they also have to be providing forces in that dimension. So the two original scales are doing two things. They're both providing leftward forces and upward forces, and downward forces, I guess. So how do you keep track of all this? How do you see what part of the two original forces goes to combating the new force? You have to do a sum of force equation in each dimension, and that's what you're going to be doing in lab. So in the Flickr album after this video, you're going to see some calculations I did as I stretched the right scale more and more and more. You're going to do those same ones in lab. And hopefully what we're going to find out is how we can keep track of all these forces in all these dimensions.